This is the only weapon system in human history that slaughtered more people during its manufacturing process than it ever killed on the battlefield. You are looking at the Aggregat 4, universally known as the V-2 rocket. It is a 12.5-ton marvel of aerospace engineering, yet fundamentally, it operated as a colossal flying chemical prison. Over 12,000 forced laborers perished, assembling these exact components deep underground, while the missile itself claimed roughly 5,000 lives at its intended targets. To understand how a machine designed to conquer the stratosphere became a subterranean meat grinder, we must rip it apart. Let us completely digitize this environment, strip away the concrete launch pad, and plunge our camera directly into the damp, suffocating darkness of the Mittelwerk subterranean assembly facility beneath the Kohnstein Mountains. Initiate a full 3D material stripping protocol on the outer hull. Watch as we peel back all 4 primary aluminum-magnesium alloy exterior panels, exposing the raw, unpainted skeleton of this ballistic leviathan. What you are staring at right now is a chaotic, claustrophobic nightmare of 30,000 individual mechanical parts, violently crammed into a narrow 14-meter cylindrical framework. There is zero wasted space, leaving absolutely no margin for mechanical error. Now, let us execute a Boolean cross-section cut right through the midsection. Observe the massive internal fuel cells. To prevent the supercooled liquids from instantly freezing the outer skin, German engineers wrapped these tanks in a thick layer of glass wool insulation, which we will now highlight in a yellow thermal grid. This primitive fiberglass material had to be packed in by hand, sending thousands of microscopic glass shards into the lungs of the starving workers who installed it. Now let us dissolve the glass wool and cut into the core chemical payload. We are isolating the 4 primary liquid solutions that made this rocket the most toxic machine of its era. In the upper chamber, we have the A-Stoff tank, containing thousands of liters of liquid oxygen, supercooled to precisely minus 183 degrees Celsius. Directly below it, separated by mere centimeters of insulated bulkhead, sits the B-Stoff tank, carrying a highly volatile, highly corrosive mixture of 75% ethanol and 25% water. But these 2 chemicals alone cannot reach the combustion chamber without violent mechanical intervention. Let us pan the camera down to the intricate piping of the turbopump assembly. This is where the true chemical horror of the V-2 lies. Zoom in on these 2 smaller, ancillary tanks tucked above the primary combustion nozzle. They hold the catalyst materials, T-Stoff, an extremely concentrated, highly reactive hydrogen peroxide solution, and Z-Stoff, a deadly sodium permanganate catalyst. When these 2 liquids mix, they instantly generate a massive volume of superheated steam, which violently spins the turbine blades at 4,000 revolutions per minute to force the main propellants downward. But before the engine ever ignited, the assembly process itself initiated a chain reaction of physical failures. Let us apply a microscopic X-ray filter to the primary liquid oxygen distribution lines. Notice the precise geometry required for these pipes. At minus 183 degrees Celsius, the aluminum piping undergoes severe extreme thermal contraction, shrinking and warping the metal at a molecular level. To survive this thermal shock, every single joint had to be hand-welded with absolute microscopic precision. Now, factor in the human element. These welds were executed in poorly ventilated limestone tunnels under the faint glow of incandescent bulbs by exhausted laborers trembling from malnutrition and hypothermia. focus the lens on this specific junction ring near the fuel injection valve. Here, you can clearly see the microscopic stress fractures, jagged microscopic canyons in the weld seam caused by unstable hand movements and impure welding rods. On the drafting table, these microfractures were a statistical anomaly. In the subterranean hell of Mittelwerk, they were an absolute death sentence. When the pressurized T-Stoff and Z-Stoff chemicals were pumped into the system for static pressure testing, these microscopic cracks surrendered under the immense hydraulic load. Highly concentrated hydrogen peroxide instantly vaporized upon hitting the humid cavern air, transforming the immediate workspace into an invisible cloud of corrosive poison. Inhaling this vapor caused immediate chemical burns to the respiratory tract, literally dissolving the lung tissue of the mechanics strapped beneath the fuselage. The German SS commanders classified these leaks as acceptable collateral damage, prioritizing production quotas over structural integrity. We are looking at a machine that demanded absolute mechanical perfection from a labor force it was actively trying to exterminate. You can see the dark, oxidized stains around these lower valves, permanent chemical scars left by the toxic leaks during assembly. Every single V-2 that rolled out of this mountain carried these hidden mechanical diseases, ticking time bombs of compromised metallurgy and corrupted welds, waiting to unleash catastrophic physical consequences once the rocket was subjected to the sheer aerodynamic violence of a Mach 4 atmospheric ascent. Re-engage the complete 3D environmental simulation. We are now extracting this compromised ballistic missile from the suffocating limestone tunnels of the Mittelwerk facility and transporting it directly to an active mobile firing stand, deep within the dense, freezing pine forests of Peenemünde. It is time to initiate the physical launch sequence and observe how the hidden mechanical diseases we just discovered react to the sheer kinetic violence of stratospheric flight. Let us activate a fully transparent wireframe overlay on the lower engine module. Zoom in on the primary turbopump assembly, the mechanical beating heart of the V-2. Initiate the pre-launch catalyst sequence. Watch closely as the highly reactive T-Stoff and Z-Stoff solutions are injected into the steam generator. The chemical reaction is instantaneous and violently exothermic. It produces a massive, high-pressure cloud of superheated steam that slams directly into the titanium turbine blades. The central impeller is forced to accelerate from 0 to exactly 4,000 revolutions per minute in a matter of seconds. Under this immense rotational velocity, the dual centrifugal pumps drag the super-chilled liquid oxygen and the ethanol fuel down through the compromised piping we examined earlier. The mechanical stress is staggering. The pumps are injecting a mind-numbing 125 gallons, or 473 liters, of highly explosive liquid propellant directly into the main combustion chamber every single second. Now let us execute a real-time thermal gradient scan across the entire fuselage. Look at the terrifying physics of this extreme temperature disparity. Down here, at the base of the rocket, the atomized alcohol and oxygen mixture violently ignites, generating a sustained, localized inferno burning at an unbelievable 2,500 degrees Celsius. The exhaust velocity of these supersonic gases generates 58,000 pounds of raw kinetic thrust. Yet, simultaneously, just a few meters above this melting combustion chamber, the A-Stoff tank remains deeply frozen at minus 183 degrees Celsius. The rocket is literally tearing itself apart through sheer, extreme thermal shock before it even lifts a single millimeter off the launch pad. The metal framework is screaming, contracting at the top and expanding violently at the bottom. Drop the camera down to the exhaust nozzle. Focus on the 4 aerodynamic tail fins. Inside the scorching exhaust plume, 4 primitive graphite steering vanes desperately attempt to vector the thrust. These steering mechanisms are being continuously eroded by the 2,500-degree blast, shedding microscopic layers of carbon every fraction of a second, just to keep the 12.5-ton behemoth upright. Now disengage the launch clamps. Track the missile as it accelerates vertically, pulling a bone-crushing 5 Gs of continuous gravitational force. It violently punches through the sound barrier, riding a pillar of fire into the upper atmosphere until it reaches a terrifying terminal velocity of Mach 4, which translates to over 4,800 kilometers per hour. At this extreme velocity, at the very edge of the stratosphere, the aerodynamic pressure pressing against the outer hull is no longer just air. It is an unforgiving, physical wall of kinetic resistance. Let us pause the simulation at an altitude of 50 kilometers. Remember, those microscopic weld fractures, the invisible mechanical scars we exposed in the underground assembly line? Watch what happens to them now under the brutal, unforgiving reality of stratospheric stress. Let us strip away the outer aluminum skin during this high-speed atmospheric transit. The intense kinetic friction heats the external hull to well over 600 degrees Celsius. The compromised aluminum joints surrounding the liquid oxygen lines, those same joints welded by starving, exhausted laborers in near darkness, finally surrender to the extreme high-frequency vibration generated by the V-2 analog gyroscopes spinning frantically in the guidance compartment. The microfractures violently snap open. We are talking about an instantaneous, catastrophic structural failure. In a fraction of a second, the super-chilled liquid oxygen leaks out and instantly violently mixes with the boiling ethanol inside a compromised high-temperature vacuum. The resulting explosion does not happen on the ground. It happens right here, on the edge of space. The V-2 tears itself into 10,000 flaming pieces of jagged shrapnel over the English Channel, completely disintegrating mid-air. It fails its strategic mission entirely, not because it was intercepted by enemy fighter planes, but strictly because of a microscopic mechanical flaw forged in the dark, toxic depths of a subterranean cave. Let us pull back the camera and project the real-world statistical combat data onto a massive 3D tactical holographic map of Western Europe. Germany launched over 3,000 of these V-2 rockets during the closing stages of the conflict. To fuel these colossal mechanical beasts, the desperate regime was forced to divert over 1/3 of the entire nation's potato harvest just to distill the massive, absurd quantities of beast-off ethanol required for the launch campaigns. They literally starved their own civilian population, draining vital agricultural resources to feed a machine that ultimately possessed absolutely zero strategic military value. The primitive analog gyroscopes, constantly thrown off calibration by the violent engine vibrations, meant the V-2 could not be aimed with any degree of tactical precision. It could not hit military factories, it could not alter the tide of the war, and it completely failed to break the psychological morale of the Allied forces. It was a weapon of pure, blind terror, possessing absolutely no practical military application. Let us drop the holographic map and return to the cold, dead iron of the rocket itself. This machine represents the ultimate fatal flaw of wartime engineering. The V-2 was not a wonder weapon. It was an incredibly fragile, terribly inefficient, kinetic projectile that actively sabotaged its own existence. It cost astronomically more financial and industrial capital to build than the total value of the targets it actually managed to destroy. But the true horrifying cost of the Aggregat 4 was paid entirely in advance. It was paid in the suffocating, hydrogen peroxide-flooded tunnels of the Kohnstein Mountains, paid with the lungs and lives of the enslaved mechanics who were forced to build it. It is a chilling historical paradox that the exact same foundational gyroscopic and propulsion technology that eventually carried mankind safely to the surface of the moon was originally birthed inside a subterranean chemical slaughterhouse. You have been diving deep into the mechanical abyss with DEFUNCT. Do not forget to subscribe to the channel, hit that notification bell, and leave a comment below, letting us know which mechanical nightmare we should dissect, tear apart, and analyze next.